On Earth, an astonishing geomagnetic storm phenomenon once occurred, which not only caused a sudden interruption in the heating system of Quebec but also led to the complete blackout of streetlights and the failure of public transportation facilities, including subways and trains. The entire city was plunged into a state of darkness and silent panic. This was the shocking Quebec blackout incident that stunned the world. What exactly happened that day? In the early hours of March 13, 1989, Quebec was experiencing a winter chill, with temperatures dropping to -20 degrees. While people were deep in their sleep, the indoor temperature began to plummet, waking everyone up in a panic. As they looked out the window, they discovered that not only were the streets outside completely dark, but the night sky was also filled with eerie auroras that could only be seen in high-latitude regions. This sudden event sent the entire area into a state of fearful darkness. This large-scale power outage, which occurred without any warning, lasted for a full 9 hours and resulted in hundreds of millions in economic losses for the paralyzed city. It was only days later, when NASA released a set of abnormal solar data, that people realized the culprit behind this massive blackout was a large-scale solar storm from 150 million kilometers away, which triggered a severe geomagnetic storm. The immense electrical currents generated overloaded the output lines, ultimately causing the power outage. As a type of space weather event, when a localized explosion occurs on the Sun, the resulting solar wind, accompanied by high-energy particles, is ejected into space at nearly the speed of light and can reach Earth within a short period of time, causing geomagnetic storms and resulting in dramatic changes in the Earth's magnetic field. When a solar storm occurs, the first thing to reach Earth is enhanced electromagnetic radiation, which disturbs the ionosphere, leading to a rapid increase in the density of the ionosphere. This causes radio signals passing through this area to experience attenuation. When the storm is too intense or in a critical zone, it can completely disrupt communication systems. Next, streams of high-energy particles begin to bombard the Earth's magnetosphere. They continuously collide with satellites in geostationary orbit, penetrating their internal electronic components and causing malfunctions in the satellite's control systems. Days later, when a cloud of plasma finally reaches Earth, geomagnetic storms begin to impact the entire electrical grid and transformers. This can cause temporary data anomalies and may even lead to permanent damage to electronic components. If astronauts were conducting extravehicular activities at that moment, these high-energy particles could even expose them to lethal doses of radiation, endangering their lives. While we, as inhabitants of Earth, benefit from the double protection of the Earth's magnetic field and atmosphere, solar storms do not pose a direct threat to human health. However, it is undeniable that we are constantly under the influence of the Sun. Even the slightest change could potentially evolve into a catastrophic disaster for life on Earth.